Good evening, and we're going to talk a little bit about the nature of geographic information. This is based on excerpts from the open source textbook by David DiBiase with contributions from various other individuals and students at Penn State University. So we're going to talk specifically about Chapter 3 of this online textbook, Census Data and Thematic Maps. Little overview. Reference maps can be defined as a set of symbols that represent the locations and attributes of entities measured at certain times. And a thematic map, well, that's a map created specifically to highlight the distribution of a particular phenomenon or theme. And this chapter explores the characteristics of attribute data used for thematic mapping, especially attribute data produced by the U.S. Census Bureau, which is one of the biggest sources of data across the entire United States. Okay, so we're going to look at two different types of maps, a reference map and a thematic map, to give you an example. This would be a reference map. In other words, it's just a map of the world as we know it at this time. This one in particular happens to be from, I believe, the 1600s, late 1600s, early 1700s. Anyway, you can see that it doesn't really particularly convey a specific theme so much as it is used as a reference for locations. Whereas this map depicts some phenomenon that is occurring across the United States and is represented how it changes across the nation relative to changes in colors, and this would be a thematic map. So, census attribute data, what are we talking about? Well, a thematic map is a graphic display that shows the geographic distribution of a particular attribute or relationship among a few selected attributes. In other words, you have some information that you want to display and map out according to some theme or some idea or some phenomenon, and that's what we do. In the United States, we do a periodic count of the entire population. This was required by the Constitution because we live in a representative democracy, and it is important that we know how many people there are in the country and where they live, because that determines how many representatives they receive, how many electoral votes are there, and all these sorts of things are all based off of the census. And so in the Constitution it specifically states that an actual enumeration shall be made every 10 years in such a manner as Congress shall by law direct. In other words, the Constitution says you will count everyone in the nation every 10 years, and we'll let the Congress decide exactly how to do that. And the way they did that was they established the U.S. Census Bureau, and it's the government agency charged with carrying out this census that occurs every 10 years. The results of the census determine states' proportions of the seats of the House of Representatives and other things like we talked about. Constitutional rules and legal procedures require that voting districts contain equal populations within about 1%, and so it is very important that they have these numbers and that these numbers be correct. In addition, districts must be drawn so as to provide equal opportunities for representation of racial and ethnic groups that have been discriminated against in the past. In other words, you can't legally carry out the practice known as gerrymandering, which is essentially arranging the distribution of your congressional districts to specifically disadvantage any groups. So, aside from reapportionment and redistricting, the U.S. Census counts also affect the flow of a whole lot of federal money. And so contracts and federal aid to states and municipalities, all this stuff, a lot of times is based solely on these numbers. So it's important that these numbers be accurate. The mandate is to provide the population data needed to support governmental operations, including reapportionment, in other words, how we redistribute tax dollar, redistricting, how we divide up areas according to how they're going to vote, and the allocation of federal expenditures where money is spent. Its mission to be the predominant collector and provider of timely, relevant, and quality data about the people and the economy in the United States. So generally, if you're looking for information about us or our economy, the Census Bureau is probably your first step. So what is the difference between enumeration versus sample? Well, if we go back in time, there were 16 U.S. Marshals and 650 assistants. that went out and conducted the first U.S. Census in 1791. And they counted what was estimated to be 3.9 million people. At that time, Secretary of State Thomas Jefferson reported to President George Washington that the official number understated the actual population by at least 2.5%. So how do you come up with these things? Well, when we talk about enumeration, we're really literally talking about counting. So like in the image on the right, this poor guy has to go through here and count every marble in the jar to know how many marbles are in the jar. Sampling refers to if we were to, for example, remove some portion of the marbles from the jar and count them and weigh the jar, and then remove all the marbles from the jar and weigh the jar again and figure out the weight of that entire group and divide it by the number of marbles, and you can eventually calculate out what you think is the actual number. And that's kind of the way it works with the population. You're not going to sample everyone, but you figure out some way of selectively collecting data on portions of the population, and you use that to mathematically infer other population numbers. And again, this is different than enumeration, where you physically would actually collect 100% of the data. By 1960, the U.S. population had reached 179 million. It was no longer practical to have census takers visit every household. And the Census Bureau then began to distribute questionnaires by mail. Of the 116 million households, 72% responded by mail. And then they had a mostly temporary staff of 800,000 people that visited the remaining households, because they do still have to visit every house and count every head. And so the final count at that time was 281,421,906. The Bureau determined that the final count was accurate to within 1.6% of the actual number. So let's take a look at some more census information. In 1791, they asked relatively few questions. They wanted to know the number of free people, slaves, males over the age of 16, as well as the sex and race of each individual. And that was about it. By the time we got to 2000, all the households were asked 6 specific population questions: name, telephone number, sex, age, date of birth, Hispanic origin and race, and 1 housing question, whether the residence was owned or rented. Now, 1 out of 6 households received what we call the long form, and this has 46 questions about housing characteristics, expenses, citizenship, military service, health, populations, employment status, place of work, whether you commute, and your income. Okay, and so from this data, which is sampled data, the Census Bureau estimates the data on all these variables for the entire population. So at the Census Bureau, the way they describe this is data that is associated with questions asked of all the households. They call it their 100% data. And data estimates from samples are called sample data. So when you're looking at census data, if it says sample data, you know that that was sampled out of 1 of every 6 homes. And if it was the 100%, if it says 100% data, it means that they literally collected that from every individual that they conducted the census on. Both types of data are available, and they're aggregated by various enumeration areas, including census block, block group, tract, place, county, and state. Through 2000, the census distributed the 100% data in a package called the Summary File 1, or SF1, and the sampled data as Summary File 3, or SF3. Every month, 1 household out of every 480 in each county or equivalent area receives a similar survey to the old long form, and they do this annually or semi-annually to get estimates produced from the American Community Service sample. And basically what they did is they replaced the SF3 data beginning in 2010. So to protect the confidentiality, the Bureau aggregates data by different types of geographical areas. For instance, the SF1 data is reported at the block or tract level. There's about 8.5 million census blocks as of the year 2000. Census blocks are bounded on all sides by streets, streams, or political boundaries. Census tracts are larger areas that have between 2,500 and 8,000 residents. A typical census tract consists of about 5 or 6 sub-areas called block groups. block groups are simply just a group or cluster of census blocks. The American Community Survey estimates that the SF3 data that preceded them are reported at the block group level or higher. So we have this new American Community Survey data, and it is very similar to the SF3, and it's reported at the same kind of context, block group or higher, but not at more specific detailed level. So again, like I said, beginning in 2010, we have this American Community Survey, the ACS. It replaced the long form. It samples 2 to 3 million households a year, and this allows the Census Bureau, their statisticians, to produce more timely estimates of the demographics, economics, social, housing, and financial characteristics of the U.S. because oftentimes 10 years might be too long to wait. You don't want to not forecast or not identify a pending economic problem because you didn't have the data simply because it was not a census year. So this is one of the things that sort of takes care of that. So international data, well, the international database is published on the web by the Census Bureau's International Program Center, and so they have a database of stuff from other countries. It combines demographic data compiled from census and surveys of some 227 countries and areas of the world, along with estimates produced by the Census Bureau's demographers. So in other words, they do some survey work, and then based on other factors they come up with the best estimates. Data variables include population by age and sex, vital rates, infant mortality, life tables, fertility, child survivorship, migration, marital status, family planning, ethnicity, religion and language, literacy, labor force employment, and income. Census and survey data are also available by a country for selected years from 1950. Projected data are available through the year 2050. And so we begin doing this in other countries around the globe in about 1950, and we use the information that we collect to do projections, and so you can get projected values for these various things in different parts of the world as far out as 2050. Counts, rates, and densities. The raw data collected during the census are counts, basically. It's just whole numbers, people, housing units, etc. The Census Bureau aggregates this by counties, by tracts, by block groups and blocks, and then it reports those aggregate totals. And you get summary measures such as averages, medians are reported. A rate such as Hispanic population as a percentage of the total is produced simply by dividing one from the other. A density such as a person per square kilometer is a count divided by the area of the geographic unit to which the count was aggregated. So that's just some rundowns of how the data can be presented. Talk a little bit about attribute measurement scale. The length standard established for the International Metric System was originally defined as 1/10,000,000th of the distance from the equator to the North Pole. I did not know that. In virtually every country except the U.S., the metric system is pretty much what's standard, and it's benefited science and commerce by replacing fractions with decimals and introducing an Earth-based standard of measurement. Standardized scales are needed to measure non-spatial attributes as well as spatial features. Data described one of 4 levels of measurement, and it's ordinal, nominal, interval, and ratio. And so we'll talk a little bit more about those. So these measurement scales. Nominal data is produced by assigning observations into unranked categories. In other words, things are grouped together into categories, but they're not ranked, and so forest is not preferred to grassland. It's simply assigning where something goes. Then there's ordinal scales produced by assigning observations to discrete ranked categories, like prime farmland versus regular farmland, and so there's a significance in terms of the rank. Some classes are better than others. Then you have interval scale. Unlike nominal and ordinal, these are qualitative in nature. Intervals are quantitative units of measurement and are arbitrary, and the 0 point is arbitrary. And so think of a number scale. Interval and ratio is very close. Ratio is qualitative in nature. the units of measure are arbitrary and a 0 point is significant. A ratio scale would be something like, I'm trying to think what we'd use here. The temperature scale in Celsius. At 0, water freezes, so there's some significance to that. Would be a type of an example. So, thinking back to some of the earlier things we talked about, thematic maps are usually made with a single purpose in mind. Typically, that has to do with revealing the spatial distribution of one or two attribute data sets. And the most prevalent type of thematic map is the chloropleth. These maps they tend to display ratio level data, which has been transformed into ordinal level classes. As far as classification of data, geographic data is always generalized. Generalization helps to make sense of complex data. Data classification is a means of generalizing thematic maps, and if chosen and applied skillfully, it can help reveal patterns and anomalies that otherwise might be obscured. And so what happens is the raw data might be overwhelming, or you might not notice the important elements. And so by classifying the data and grouping things together under single values or labels, you might identify patterns that simply looking at the raw data in its whole context you wouldn't see. Now, by the same token, though, poorly chosen classification schemes can hide the meaningful knowledge that's hidden there in the data. The appearance of a thematic map and sometimes the conclusions drawn from it may vary substantially depending on the classification scheme that is used. So you have to be wary of that. So, in summary, the national census are among the richest sources of attribute data that you'll find anywhere in the U.S. Attributes range in character from qualitative to quantitative, from unranked categories to values that can be positioned along a continuous number line. The level of measurements used to define a particular data set influences the analyst's choices about which analytical and cartographic procedures should be used to transform the data into geographic information. Thematic maps help transform attribute data by revealing patterns obscured in simply lists of numbers. And classification schemes that facilitate comparison of map series such as quantiles and equal intervals are among the most common.